RenderForce.com.
Hi and welcome back to this OpenGL tutorial. In this tutorial we complete the previous lesson understanding the homogeneous transformation matrix. Homogeneous transformation matrix as an instrument that allows us to express position and orientation between two different frames. This transformation matrix allows us to place an object in the OpenGL world with specific position orientation respect to a particular frame. In general, we have the following situation. We have an object and every point or vertex of the object is expressed respect to a frame attached to the object itself. In this case, we have a cube and the frame VSU attached to the cube. Our goal is to express every vertex of the cube respect to the frame x, y, zeta. So, let be PVSU any point expressed respect to the frame VSU. So, PVSU is the vector positioned in the frame VSU that identify every point of the cube respect to the origin of the frame VSU. From the previous lesson, we know that the rotation matrix allows us to transform vector between two different frames. So, we need to transform the vector position PVSU in a vector expressed in the frame x, y, z. And we can use the rotation matrix that expresses the orientation of the frame VSU respect to the frame x, y, z in order to compute this transformation. If we sum this transformed vector with vector O, x, y, z between the origin of the frame x, y, z and the origin of the frame VSU, we can compute the position of any point of the cube respect to the frame x, y, z. And this position vector or this point is pxyz. So all vectors in this relation are column vectors. If we using homogeneous coordinates, we can express this relation in another compact form. And this is the form that allows us to extract the transformation matrix that we can express in a block form. This matrix allows us to transform a point expressed in the local frame of the object in a point expressed to the whole frame, for instance. Now we are ready to see this mathematical expression in action in our program. If we remember the previous lesson, we have already defined the homogeneous transformation matrix, but we have only considered the rotation matrix part. In order to complete the homogeneous transformation matrix, we want to define another method. We call this method placeObject. The interface of this method accepts the Euler angles in order to define the orientation of the object we want to draw, plus three other parameters in order to define the position in space of the frame attached to the object. These values are placed in the last column the fourth column of the homogeneous transformation matrix. And with this operation we have completed the homogeneous matrix definition. So we want to use this new method in order to draw 4 cubes in space in a different position with a specific orientation that we want to change in time. Okay, of course we want to express the position and orientation of each cube respect to the world frame. So we need to save the current model view matrix and restore the current model view matrix after drawing of each cube in the scene. So we want to draw the first cube in the following position with this orientation, another cube with this position and this orientation, and so on for the last 2 cubes. Okay, we have ready to start the application. And this is the result. We have the world frame and 4 cubes in different position, and with each rotation that change in time. Okay, the lesson is completed. In the next lesson we start to develop the 3D scene for a 3D level with quake texture in order to develop a more complex level. Okay, see you soon in the next video, and thanks for watching.